that? Watch this! This is the heavy monster sound. The nuttiest sound around. So if you coming up the street...
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. I am Amirul Haziq bin Roslin. My matrix number is... And today, this video is all about experiment 4, which is the effect of heat treatment on microstructure of steel. So without further ado, let's start our video. Based on the video that my lecturer, Sir Hedril, has given to me, I have chose grinding process to do as a DIY video. The first step is to open the water valve and wet the surface of the grind. We wet the surface of the sandpaper so that when we grind our sample, it won't damage the sandpaper. Secondly, make sure the sectioning of the sample is perpendicular to the grinding machine. This because it's in order to avoid from having uneven surface. Thirdly, grind from the lowest grade, which is 240 grade, 360 grade, work all the way up to 1200 grade. After that, close the water valve and let it air dry. Since I don't have any steel, I use wood as my substitute. These gloves act as neutral gloves. These act as safety glass. This is the sandpaper, which represents grinding machine. Use gloves before hand sanding, unless you really want to hurt yourself. Make sure to use the right grade sanding for your sample. Grease the grid once you feel that the surface can't be smoothened anymore. As you can see here, I have a large piece of sandpaper. Therefore, it is the best to cut your sandpaper according to the size of your sample. Here is a footage of the side that I did not sand. And here is the footage that I just sand just now. This is the sound of unsanded side, which is really rough and you can hear it. This is the sound of the sand side. You can hear that it doesn't have that rough or any debris. This is the result under the microscope. The reason for the etching process in the planning of the metallographic sample is to reveal the microstructure of the sample. Firstly, sample needed to be cleaned and dried by using alcohol. After that, the sample will be submerged into etching reagent for a few seconds. And then, all of the traces of acid will be removed by putting it under the steam of water. The watermark can be prevented by washing again with alcohol. And sample is heated to specific temperature, and then sample will be whole and soaked at the temperature for a specific time. Sample will be cooled down to a room temperature slowly, thus producing a fine-grained structure, which is process annealing and for full annealing will produce coarse pearlite. Next is normalizing. Steel will be heated above 55 degrees Celsius to 80 degrees Celsius. This is the temperature above hypol and hypolite. Sample them will be completely transformed into austenite after sufficient time, and then the steel will be removed and cooled down to the room temperature. Therefore, this will produce fine pearlite. Sample will be quenched after heated steel to 30 degrees Celsius to 50 degrees Celsius above upper critical temperature. This will produce martensite. Tempering. Steel will be heated after quenching, usually around 250 degrees Celsius to 650 degrees Celsius. Then the steel will be stay at the same temperature for 2 hours long. After that, the sample will be removed from the bath and let it cool to room temperature. Therefore, this will produce tempered martensite. Martensite is also known and referred as a very high form of crystalline structure or any structure formed by diffusionless transformation. Martensite crystal structure is body-centered tetragonal. Because of this, there is a few slip planes making the sample hard and brittle. Under the microscope, we can see that martensite is actually needle-shaped. So what I can conclude from this experiment is all of the objectives have been achieved. The purpose of this experiment is to relieve the internal stress, improving ductility, machinability, toughness, and increase strength and hardness. The sample has undergone a few procedures, which is cutting, molding, grinding, polishing, and lastly, etching. This is all from me. Thank you all for watching.